Imagine showing a child one picture of a zebra. Just one. And from that single example, they can recognize every zebra they'll ever see. In photos, in zoos, in cartoons. Humans do this effortlessly. Now imagine telling a machine learning model to do the same thing. Traditional AI says, sure, just give me 10,000 labeled examples, a GPU cluster, and 3 weeks of training. That gap between human learning efficiency and machine learning hunger has haunted AI for decades. But what if machines could learn like us? What if a model could classify with 0 examples? Or master a new task from just 3? Today, we'll see how modern AI is closing that gap, and why it changes everything about how we build intelligent systems. Let's put this revolution in perspective. In the 2000s, machine learning was all about big data. More data, more accuracy. Models were hungry. They needed millions of labeled examples to work. Then transfer learning changed the game. Pre-train on massive general data. Fine-tune on your specific task. Now you needed only thousands. Few-shot learning pushed even further. Show the model just a handful, 1, 3, 5 examples, and it generalizes. And then came zero-shot. 0 labeled examples. The model has never seen your task before, and it still gets it right. This isn't magic. It's the result of 3 breakthroughs working together. Massive pre-training gives models world knowledge. Language understanding lets them interpret new instructions. And prompt engineering lets us communicate exactly what we want. Zero-shot learning, classifying something you have never seen labeled training data for. Sounds impossible, right? Let's see how it actually works. Traditional classifiers need labeled training data. No labels, no model. Game over. But zero-shot flips this completely. The most elegant trick uses natural language inference, NLI. Here's the beautiful idea. Instead of training a classifier, we reframe the problem. Take any document and ask, does this text entail the hypothesis that it's about sports? The model says, input, the team scored 3 goals in the second half. Hypothesis, this text is about sports. Result, entailment, 94% confident. Try politics, only 8%. Try cooking, 3%. No training labels needed. The model just uses its understanding of language to judge whether a statement supports a hypothesis. Clip took this into images. Show it any picture with any text description, and it rates how well they match. 0 labels. 0 training data for the specific task. Is zero-shot as accurate as supervised training? Usually no, there's a performance gap. But here's what matters. When you have NO-labeled data, 82% accuracy from zero-shot beats 0% from a model you literally cannot build. If zero-shot is the model thinking on its own, few-shot is like giving it a cheat sheet. In-context learning is the core magic. You write a prompt with a few labeled examples, and the model learns the pattern on the fly without updating a single weight. Watch this. Just 3 examples in the prompt. Best pizza I ever had maps to positive. Waited 2 hours, food was cold maps to negative. Nothing special, average meal maps to neutral. Now classify. The pasta was life-changing. The model sees the pattern, reviews map to sentiments, and nails it. No training. No GPU. Just clever prompting. Here's the beautiful thing about scaling. Going from 0 to 1 example is huge. 1 to 3, still valuable. But 3 to 10? The gains flatten dramatically. You get 80% of the benefit from just a handful of demonstrations. More formally, this is meta-learning, learning to learn. Models like MAML and prototypical networks are explicitly trained to be good at picking up new tasks from minimal examples. They build internal representations that make new tasks easy. Think of it this way. Traditional machine learning is the student who reads the entire textbook cover to cover. Few-shot is the student who reads 3 practice questions and aces the exam anyway. Few-shot learning is only as good as your prompt. And prompt design is rapidly becoming its own engineering discipline. A well-engineered prompt has 5 parts: clear instructions, format specification, carefully chosen demonstrations, the actual query, and an explicit output format. Chain of thought prompting was a game changer. Instead of asking for just the answer, you ask the model to think step by step. Show it examples where the reasoning is spelled out clearly. Suddenly, the model solves problems it couldn't handle before. But here's the catch. Prompts are fragile. Change just one word, classify to categorize, and accuracy can swing by 10 percentage points. The order of your examples matters. Even the formatting of your demonstrations changes results. That's why we now have prompt optimization tools that automatically search for the best template, select the most informative examples, and calibrate model confidence. Prompt engineering went from an art to a science. Few shot and zero shot sound magical. Problem solved, right? Not. So, fast. Meet the clever Hans problem, named after a horse in 1900s Germany that could supposedly do math. Turns out, Hans was reading his trainer's subtle body language, not actually calculating. Few-shot models have the exact same issue. The model might look like it learned your task from 3 examples, but often it's just pattern-matching surface features, keywords, positions, formatting cues, not truly understanding. Failure number 1, majority label bias. If 2 of your 3 examples are positive, the model often predicts positive for everything. It learned the frequency distribution, not the actual task. Failure 2, recency bias. The model disproportionately copies the last example's label. Negative example at the end, everything becomes negative. Failure 3, prompt sensitivity. Same task, same model, same data, different wording. Accuracy swings from 42% to 91%. That's not robust intelligence. That's a coin flip with extra steps. And the scariest part? You usually cannot tell when it's failing. The model doesn't say, "I'm confused." It says, "I'm 95% confident," and gets it completely wrong. Few-shot learning is powerful, but deeply unpredictable. Knowing these failure modes is just as important as knowing how to use it. So how do you choose the right approach? Here's the practical decision framework. 0 labeled examples? Use zero shot, perfect for rapid prototyping, brand new categories, and breaking news events. 1 to 10 labeled examples? Few shot in-context learning. Fast, no training needed, good enough for most tasks. 100 or more labeled examples. Fine-tune a smaller, specialized model. More consistent, cheaper to serve. 10,000 plus? Full supervised training. Still the gold standard when maximum accuracy justifies the investment. The real-world impact is massive. Few-shot is already classifying medical papers for rare diseases with fewer than 100 known cases. Zero-shot translates endangered languages with no parallel text data. Content moderation systems detect entirely new types of harmful content before they go viral. Here's the mind-blowing stat. GPT-4 with just 5 in-context examples now matches models trained on 10,000 labeled examples, on 23 out of 30 standard NLP benchmarks. The era of you need millions of examples is officially over. This is video 3 of Unit 3. V1 covered information extraction. V2 explored document-level NLP. Now you understand how AI learns from almost nothing. Next up, combining few-shot with advanced prompting and instruction tuning. That's where the real power unlock happens. Subscribe. Hit the bell, because from 0 examples to 0 limits, that's where NLP is heading. Let's keep going.